Okay, welcome back everyone. Hope you're doing well today. This quick introductory video or this part one of today's lesson is just an introduction or an explanation as to what equations or what steps and kind of what we're going to do today. So the essential question is, how can we find the area under a curve using antiderivatives? Okay, so what we've been doing the last couple of days is we've been finding area under the curve using rectangles. We're not going to use rectangles anymore. We're just going to use antiderivatives because, quite frankly, it's quicker and it gives you a more accurate answer. Okay, so assignments right here, and let me just start by going back to those rectangles, and let's take a look at a graph. All right, these two are the same curve. Okay, or they're pretty close to the same curve, the blue curve here. So let's say you want to find the area from some interval a to b, and you're drawing these rectangles. Okay, well, let's say, and I didn't really finish drawing my rectangles here, but let's say we went all the way to the end. If you're looking at this, the accuracy of your answer kind of depends on the width of your rectangles, right? If you've got thick rectangles here, you're missing some pretty big spots. You're either underestimating or overestimating over here. Those are some misses in your answer that you're going to have to account for, okay? Well, looking down here, if you thin up those rectangles, you may get a slightly more accurate answer just because the rectangles are packed in tighter, but you're still going to have little areas right here of inaccuracy, right? You're going to be underestimating right there, overestimating on this side. So the smaller these rectangles get, the more accurate your answer gets. However, like I said, there's still going to be some inaccuracies there, okay? So what we do with integration is, or antiderivatives, is if we look at a curve, okay, and let's say we want to get the most accurate answer possible for area under a curve, what we do is we take an infinitesimal number of rectangles under this curve. I know that's hard for the mind to imagine because infinity is not a number, it just goes on forever. But mathematically, to get an exact answer or an accurate answer for area under the curve, you need to have an infinite number of rectangles under this curve that you can take the area of and get an answer for area under the curve. So when we look at this equation, this is something you can get in your notes, limit as n approaches infinity. So that means as the number of rectangles approaches infinity, okay, this means sum, so you're summing all those rectangles together from 1 to infinity of whatever function you're graphing. That's going to give you the area under the curve, okay? Another way of writing this limit is the same thing as writing, and this is what we're going to use today and for the foreseeable future. This limit is equal to, or the same way of writing, the integral, or the antiderivative, from a to b, okay, a to b, of that function, f of x dx, okay? This is called a definite integral, okay? The reason it's called a definite integral is because you now have limits that you're looking at. It's not an indefinite integral, okay? So again, just going back, what this means is you have an infinite number of rectangles in here that you're adding together, which gives us this limit equation. But this limit equation isn't necessarily what we're going to use. This is the same as taking the integral from a to b of that function. When we get that, that's going to help us get to the area under the curve, okay? But that's only one of the steps, okay? So next piece in your notes, and I think this is going to be my last one here before I go into the next video. I'm going to have you guys write these 3 steps down because these 3 steps are what we're going to use on every problem today. So take the antiderivative, subtract the upper limit minus the lower limit, simplify, and then you'll have your answer for area under a curve. Okay, so when you have those three things written down, you can stop the video and let's go on to our examples on the next video.